My name is Tautvilas. I am a software developer from Wix.com, Lithuanian department. And today I wanted to talk to you about programming. I have been attending conferences before, and actually an idea for this talk came to me during last Build Stuff, because I was visiting all these talks, and most of them were about a certain subject, a certain framework, technology or methodology, but I thought, no, but why don't we have a talk about programming, about what it is, why is it so important, and where did it come from? And I thought, you know, these are interesting questions, and I don't think I know answers to them. So I thought about it for 1 year, and now I'm back, Build Stuff, and I'm going to tell you what I figured out. And I hope you will like this talk, and it will give you a new perspective about what you are doing every day, and I hope it will inspire you to continue programming. So for me, it all started with a question. So what is programming after all? Of course, it's something that we do every day, and I will not argue with that. You know, programming is our daily job. But when I asked several of my colleagues to define programming in words, I got very different responses, and I figured out that there is no good universal definition of programming in general. So that makes it an interesting question. And programming is a really diverse topic. So we can program games, simulations, all kinds of business apps and websites, anything really. So in order to define programming, first we have to find some kind of common ground to all the programs. And it will be easiest to do that by first defining of what programming is not. And next slides might be a little bit controversial, so don't start shouting if you don't agree. But don't forget to ask questions, and hopefully we will discuss them after the presentation. Okay, so in my view, and not only my view, programming is not science. Although we have computer science in university, and this title gets a lot of people confused, but in my understanding, and I have some understanding of science, I have a Master of Biophysics and a Bachelor of Computer Science. So as I see, programming is not science because we don't use scientific method in it. And by scientific method, I mean observing the world, making a hypothesis, then performing an experiment, and documenting the results of it to confirm or reject the hypothesis initially proposed. So this is a method at least I'd never do in my daily work. I don't use scientific methods, so thus I would say that programming is not science. Programming, I think, is also not math. Of course, we use math in programming. Our programs are composed of functions which can be mathematical functions, and math is a big part of programming. But it is not the goal of programming, not the purpose of it, and it is more like means to an end. Like in many areas we use math, and in programming we use it a lot, but a program which could do some fancy calculations but would not have any real-world application would be completely useless. So it's not only about math. And the third point I want to make is that programming is not about electronic computers, because generally any program that you write can be understood by human beings. So computer is an intelligent agent that can interpret these abstractions that you write, but any program you can give to another person, he can understand it, he can interpret it, and he can execute it, maybe slowly. But, and I'm not the only one who says this. Also, Dijkstra said one time that computer science is no more about computers than astronomy is about telescopes. Computer is a tool we use in programming. Okay, so these three things we rejected, and now what is left? So what is programming all about? What is the fundamental common ground to every program, no matter if it's the big program or it's the small program? And in my view, that common ground is abstraction. Programming is all about abstractions. It's actually the stuff that we are building. Build stuff, you know, get it, a joke. So yeah, it's the basis of every program. And is abstraction, okay, in order to continue this presentation, I also have to define what I mean by abstraction, because abstraction is a word that is thrown around, we throw it around every day, and we use it in a lot of different contexts, but here, what I mean by abstraction is in the fundamental sense. And the fundamental sense, let's say there is an example that we have, you know, an apple. What is an apple? An apple is a bunch of molecules, atoms floating around in cosmos, and we as humans, with our human brains, have the capability to identify the apple out of all of this mess and convert it to some kind of a symbol. And then this symbol can be passed over to other persons as information. So this is what abstraction really is. It's making a reduced image of the world that can be then transmitted on some specific purpose. If we look at Latin translation of the word abstraction, that there are two Latin words, and they mean to draw away from, which implies that abstraction is the process of separating one thing from the whole, from a wholeness, and giving it a name, or assigning a symbol to it. So this is the very basic definition of abstraction that I will base my talk on. Okay, so programs are built from abstractions, right? What are the other important things for human civilization that are composed of abstractions? So one such important thing is the map. It is a tool that human beings have been using for quite some time now. It is very important to us, because the process of map making is a process of transforming territory into abstracted space. That means that the purpose of the map is to understand the space, to convert space to symbols, and the use of the map is that it helps us to get orientated. We don't get lost. So it is extremely useful for our civilization, this process of abstracting space. So if I have a map, I can agree with you where to meet. If I don't have a name for a place where to meet, then it's completely useless. The other important tool that we have been using for quite some time is the calendar. And calendar is the tool that humans have been using to abstract space. Generally, the flow of time is continuous. But if you want to talk about time, if you want to agree on something in time, we need somehow to split the time and to give names on certain periods of time, and then we can agree what and when we can have to do. So it helped our civilization tremendously, and it was one of the first inventions. So if a map is a tool which abstracts space, so calendar is a tool which that abstracts time. And of course, after the calendar, there was invented the clock, which is more precise, but basically it has the same purpose than a calendar. Okay, so there's a bit of history, and now we go back to modern day, and we know that we invented the computer, and computer is a fairly recent invention. But if we look at the computer, and a computer is a device that basically understands our programs. So it has three basic parts in it. it has three basic parts in it. It has to have some kind of memory, it has to have some kind of clock in it, and also some way to do logic. So basically, in order to understand our programs, our abstractions, a computer has to have a way to abstract space, which is done by memory, a way to abstract time, which is done by using an internal clock, and it has a third component, which is logic, and logic allows these two types of abstractions, space and time abstractions, to interact between each other in time. So that's the third part, which from here we can see that our programs are more than just abstractions of space and just abstractions of time. They are abstractions of space-time. And by space-time, actually it's a definition of reality. Space-time is a synonym of reality. And so a program is a composite abstraction. It involves everything that's going on, and the purpose of the program and the benefit of a program is that it helps us to understand reality and to not get lost in it, to get organized in reality. So that's why our civilization finds programs so important, and we see more and more programs in everyday lives. All right, but as I talked about maps, for example, and calendars, these are very ancient inventions, and these are the purposes of abstraction of space, abstraction of time. So is abstracting space-time something new for human beings? Is it something we invented just 100 years ago? And I don't think that's the case, because there is one tool which is more ancient, I think, than maps and calendars, and the purpose is the same as programs. One of the purposes, it's language. And if you look at an example sentence like this, you can see that in our language we have the facilities to abstract space-time and to add some logic to it. And for example, looking at this sentence, so, and of course language was tremendously important to our society as it developed. So now what's wrong with natural language? Why did we have to invent programming languages and stuff like that? Because the sentence you saw before, it can be transformed to a programming language, and this program can be understood by a computer. Supposedly it has variables when evening, you, garden flower, and so on defined. If it has these variables defined, then a computer can understand the sentence that was passed to it. But the problem of natural language, of course, it is that it is so diverse. We are not only transmitting instructions with natural language, we also transmit emotions. It is something sometimes not very exact. A lot of things are being implied. And for a computer, since it is a fairly stupid device, it is hard to understand natural language, and we don't have a good recognition yet of natural language. So we had to invent precise, discrete languages which computers could understand, and this empowered us by creating computers, by creating computer languages, to create intelligent agents that are not human beings but can understand our abstractions and also compute them in much better efficiency than as humans do a lot of the time, at least in some specific cases. And computers really made our maps of reality interactive and dynamic, and this helped us a lot to develop our civilization. Okay, so these are two words that we know. There is programming and coding. I know this is basically the same, but what I want to what I want to say is that basically we can have these two words and they can have a specific meaning, because programming is basically the art of creating these abstractions. But creating abstractions today is not enough, because we also have to encode these abstractions to computer languages. And only then we can actually run them on computers. So that's why we have two terms. We have programming and coding, and basically we need both of these things to run a program. Okay, so but it is really completely not really necessary to have the coding part. If a computer could understand our programs, the way we speak about them, the way we speak with natural language, then there would be no need for coding in general. So I would like in the next few slides to have some predictions about the future. And okay, at least now we have in my company this product creation flow, programming flow, where a product person creates some kind of a wireframe, some kind of a mock-up. He defines all kinds of behaviors. Then this is transformed to a design, and a programmer is transforming all these things to code, to things that computer can understand. But I think in the future the coding part will still remain, but it will not be so important, because basically all these a lot of these programming abstractions are being already thought by a product person. And if we had some kind of intelligent programming environment which could understand the intent of a product person, then he could already make a wireframe of a program itself by himself without the need of the coder. And in the future it will be more like of a composition of these elements, because a product guy can create already a wireframe of a program logic, then designer can work on the same wireframe and apply a skin like a design to it. And of course coding will be necessary to implement some hard parts, some integrations, some optimizations, but basically the power of program creation will shift towards the product person, will towards the guy who thinks about it, about the use cases and stuff like that. And I don't think we have such technology yet, but there are some possible examples which can be considered like some kind of embryonic form of natural programming language. So, for example, one of the examples itself is could be considered a Wix editor, because we know that previously if anybody wanted to create a website, they had to find a coder. And now already this is shifting, the power is shifting towards a person who wants to get the job done, and if he doesn't have to search for another person to code, so he can use the editor, which is a programming interface in a way, to create his business logic and his components. Another good example, interesting example, is Quartz Composer. It's an Apple application which allows you to do visual programming and do it by connecting components and defining all kinds of interactions with them, and rendering all kinds of fancy graphics with this visual programming language. Another very well-known example of say easy and widely used programming is done in Excel, because a lot of business people use it, and it really solves problems of a lot of people. They can input their business data to that spreadsheets. We can get all kinds of visualizations, advanced functions, and all kinds of stuff from Excel. And for small-scale operations, it works pretty well. So I imagine that with advancement of artificial intelligence and new kind of paradigms in programming, we will be shifting towards more and more environments like these, which will empower people to create programs by themselves. And to finish my presentation, I would like to say that really I think programming is fundamental to us, and it's a big part of what we are as humans. And this was the aha moment for me, that I realized that programming is something we did for a lot of time, and hopefully we will find more effective ways of doing it even still, and it will help us to advance our civilization, to make us more organized, more effective, and more failure-proof. Thank you. So I don't know if there are any questions. I will take a look. Okay, no questions. If you want to give any, you can do it now. Okay.
How you just differ programming versus developing?
I think it's hard to differ. Basically, the question was how do they differ programming versus developing? Well, I think it's basically the same. All these terms are like intertwined together, and it's really hard to make a hard separation between them. So basically there is a spectrum of activities, and just what I wanted to make clear, that that programming, it doesn't have to deal with programs, with computers, I'm sorry, and actually if we want to make our programs effective, maybe we want to think in this higher level than just only about hardware, only about computers and stuff like that. Anyone?
How it differs from what we already had, that we build the blocks and then there's a code behind that generates everything.
Can you repeat?
How it differs that we already had this, like we are drag and drop stuff, and then there is a code behind that's generated by the program.
Right.
And then you're saying that.
Yes. So you say that no matter what, if we have an intelligent system that is gonna generate code for us, somebody will have to code the system. That's right. So that's I didn't want to say that coding will be obsolete, but what I want to say that it will be it become less relevant in a way that we will have less coding jobs, and there will be more like this high-level programming. So of course we will still need people to maintenance all the bottom of the systems, but there will be more and more intelligent systems that will obsolete a lot of low-level coding. So the coding will remain, but yeah, it will be less of it. Okay, thank you very much.